I'm being asked to solve for the mass of iodine. So we're solving for grams of iodine that can be produced when we pass a current of 10 amps. And remember, amps just means coulombs per second. And we're passing this through a solution of aqueous potassium iodide for 30 minutes. And so 30 minutes just really means times 60 seconds. That's going to be 1800 seconds. Okay, what reaction is happening here? We're starting with aqueous potassium iodide, and so inside of that is iodide ions in their aqueous form, and they are gaining electrons and turning into I2. Now, we're not balanced for atoms or for charge. I see here I'm going to need 2 iodines on the left. So that means I need 2 electrons in total here to balance out the charge, because I know each iodide ion is gaining 1 electron, but since there's 2 iodides, 2 times that 1 electron gives me a total of 2 electrons being transferred. All right, so let's calculate the mass of iodine. Question mark here. So let's start off with our time. We have 1800 seconds. And we are going to multiply that by the current of 10 coulombs per second. 10 coulombs for every 1 second. That's this part here, your 10 amps that we are using. Seconds cancel out. And now to convert your coulombs over to electrons, I know that 1 mole of an electron is equal to 96,485 coulombs. That number is Faraday's constant, the F on your equation sheet. You don't have to memorize that, but know that it is on your equation sheet. We use it so much, you're probably going to become very familiar with it. All right, now coulombs cancel out. You are going to want to convert now to moles of iodine. Looking at your balance equation, look at the stoichiometry. For every 1 mole of I2 produced, iodine, 2 moles of electrons are required. So 1 mole of I2 is equal to 2 moles of electrons. Moles of electrons cancel. And just go one more step, guys. We are going to convert this over to grams using the molar mass. 253.8 grams of iodine. For every 1 mole of iodine, moles of iodine cancel, and you are left with a unit of grams of iodine. Finishing up this calculation, you're going to get 24 grams of iodine produced by this reaction by running 10 amps of current through this electrolytic cell for a total of 30 minutes.